Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Dutch Flatmates Tessellation by AQJHS, and here are the rules. We have tessellation rules where we need to place the digits 1 through 9 place digits from 1 through 9 in each square and octagonal cell. So we need to place in every cell in the grid a digit from 1 through 9. Cells sharing an edge cannot have the same digit. So for example, whatever digit, if say there was a 3 here, the digits which share an edge with it, which are these 8 cells, cannot contain a 3 if that were the case. And finally, each horizontal row and vertical column contains a non-repeating consecutive set of digits in any order, which is basically the Renban rule, right? So you could have something like, say, 2, 6, 5, 3, and 4 here, and that would be valid because along this column, you form a Renban of 2, 3, 4, 5, and 6, which is consecutive. What else do we have? We have Dutch flatmates, where every 5 in the grid must have a 1 directly above it or 9 directly below it. It may have both, but it doesn't need both. Interesting. So this is actually not valid because we don't have a 1 above this 5 or a 9 below it. So that is not valid because of Dutch flatmates. Every 5 has to have at least a 1 above it or a 9 below it. At least one of these two. So that's an example of how Dutch flatmates work. And finally, we have adjacent digits along an orange line must have a difference of at least 4. These are also known as Dutch whisper lines, but I like to call them whisper 4 lines because that clarifies things and you can extend it more. So, for example, if this were, say, a 3 here, this would have to be a 7, an 8, or a 9 because those are the only digits which are 4 or more away from 3. But we have Dutch whispers along with Dutch flatmates on this tessellation puzzle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. This is a triangle here. That means one of these digits is 4 away from both of these, but these two digits also must be 4 away from each other. The only possible combination that works with in the digits in normal Sudoku, which this is essentially a variant of, is 1, 5, and 9, right? What digits can be 4 or more away from 1? It's 5 through 9. And what digits of those, what pairs of those can be 4 away from each other? It's only 5 and 9. If you try like 2, the digits are 6 through 9, and none of those can be 4 away from each other. Same with 3. 3 is 7, 8, and 9, none of which are 4 away from each other. So that's how you know this has to be a 1, 5, 9 triplet. All of these digits see this cell, so this cannot be 1, 5, or 9. Which means it must be... This has to be 2, 3, 4, 6, 7, 8. We don't know which. One of these two must be a 5. Because if you try to have 1 and 9 together, that doesn't form a Renban correctly for 5 unique digits. So one of these is a 5, which means this cannot be 5. This cannot be, it could be 5 if this is 1. If this is 5, this has to be 1. So if this is 5, has to be a 1 to have a 1 above it. You can't have a 9 below it. And if this is 5 and 1, this is 9. So if this is 5, this has to be 9. This is 1. 5, 1, 9. If this is 5, wait, we already did that. So if this is 5, this has to have a 1 above it, so that's 1, that's 9. If this is 5 here, this must have a 1 above it, so this is 9, and that's 1. Oh, that's not possible. So say this was 5, then that would force this to be 9 and 1, but that can't be a 7-length rim band, right? 1 has to be with up to 7, and 9 would be with down to 3. So this cannot be 5, therefore this is 9, this is 1, that's 5. And this must be the digits 6, 7, or 8. 6, 7, or 8 are 4 or more away from 2 and 3 specifically. 4 could be here if this were possible to have a 9, but you can't. This also must be 5 through 9 here to form a ren band, and 5 in this cannot have 1 above it. So 5 has to have a 9 below it. So this is 5 then. This is 6, 7, 8 also. Remaining digits in row 6 are 2 through 4 and then 6, 7. Six, 7, 8, it can be... So the remaining digits in column 6 also are 2, 3, 4, 6, 7. Well, 6 and 7 cannot be 4 or more away from 6, 7, or 8, so this can't be 6 or 7. This is 2, 3, 4. This is 1, 2, 3, 4 to be 4 or more away from 6, 7, or 8. Since this is 2, 1 through 4, this is at most 4, 5, and 6 here. But you cannot have... If you try to have a 5 here, the problem is that you don't have a 1 above it, right? 3, 4, and 5 is the max run band you can have for a 3-length column or row. So, or 5, 6, 7. So you wouldn't have... So this cannot have a 5 here. None of the 3-length ren bands can have a 5 in it. So since this is 1 through 4, this has to be 2, 3, or 4 here. And this is 1 through 4 here. With a guaranteed 2 and 3 here. So it's either 1, 2, 3 or 2, 3, 4 here. So this cannot be 2 or 3. It cannot be 5. 2, 3, or 4 is only... So 4 cannot be here because it cannot be 4 or more away from 2, 3, 4, 6, or 7. So this is 2 or 3. This has to be 6 or 7 here. Okay. This is 6, 7, and 8. So this cannot be 6, 7, and 8. It has to be 1, 2, 3, 4 cannot be 5. If it's 5, it doesn't have a 1 above it or a 9 below it. And it could be 9 potentially. Because it could be still 3, 4, 5, 6, 7, 8, and 9. But if this were 9, it doesn't have a 5 above it, so it can't be 9. So this is also 1 through 4. We can't have a 5 here. So again, this is 2, 3, or 4 here. Okay. 5, so 5 cannot be in any of row 1 or 2 or 8 or 9, or columns 1, 2, or 8 or 9. Because to form a 3-length rim band, well, if in the 1-length columns and rows, obviously it doesn't have a 1 above it or a 9 below it. And in the 3-length ones, Oh, I guess in the rows it could have a 5. So this is actually not, this is not correct. But this is still 1 through 4 here. It's in the columns, in columns 2 and 1, 2, 8, and 9 that you can't have a 5. Because you can always have a 5 with a 1 above it or a 9 below it in the rows, right? Huh. Okay. So this cannot have a 5. This could have a 5 here if that's 9. So that's possible. We are guaranteed a 5 in one of these 3 cells. It has 6, 7 with 6, 7, or 8. So that means the remaining digits in that row are 3 through 9. With a 5 guaranteed here. So that means 6 is guaranteed in one of these 5. So is 7. Okay. This digit could be 2 or 3. Again, cannot have a 9 here because that doesn't have a 5. If you have a 9 here, that means the digits on this column have to be 3 through 9, and then 5 doesn't have an opportunity to have a 1 above it, and it can't be here with a 9 below it, so that doesn't work. This has to have a 5 also, and one of these must be 5. This can't, if this is 5, this has to be 9. If this is 5, this has to be 9. If this is 5, this has to be 1, I guess. Okay. Oh, that's interesting. So if this is 5 and this is 9, the problem is this has to be 4 or more away from 9 here. And since that would be 5 and 9 here, this has to be a 5, 6, 7, 8, 9 Renban. But none of the other digits from 5 through 9 are 4 or more away from 9. So this cannot be 5 then. So 5 and 9 could be here, and then 5 and 1 could be here. Okay. So either this is 5, which forces that to be 9, or this is 5, which forces this to be 1. And you can never have 1, 2, 3, 4, 5, and then 6, 7, or 8 here as a 5-length Renban. So this must be 5 and 9. So this is 5, which makes that 9. That means the remaining digits in the column are 6, 7, and 8. 6, 7, and 8. We have a 6, 7, 8 triplet in row 3 now, which eliminates 6, 7, 8 in the rest of the row. So this has to be 5, and it's with... This has to be 4 away from each other at least. So this has to be a 5, 9 pair. Because 5 is not 4 or more away from 3 or 4. Okay. This 5 has a 9 below it. One of these is 5, which means either a 1 is above it or a 9's below it. This can't be 9. So... 9, the only digits which are 4 or more away from 9, which can be there. 5, again, cannot be on a 3-length column. Because if it is, it would have to be a Renban of 3, 4, 5, or 5, 6, 7, and doesn't have a 1 or a 9 above it. So this must be 1 through 4 here, which means this cannot be 6 or 7, because again, this can't have a 5 on it. So 1 through 4 must be with 1 through 4 here. 1 through 4 is on a length, 4 has a distance difference of 4 with 5, but it can't be 5 in the one length columns. So it'd be 6, 7, 8 here. This is guaranteed also to be 2 and 3. So we have a 2, 3 here and a 2, 3 here. Guaranteed. This is 2 and 3. This is 2 and 3. That means in columns 2 and 8, and in these two cells, we have a guaranteed 3 2s and 3 3s. That's the most you can have in those columns. Actually, we have a 2, 3, 4 triplet in row 6, which eliminates 2, 3, 4 in the rest of the row. Can't be 2, 3, or 4. But, yeah, we already have 2, 3, and 4. We have 2. We have a 2 here. We have a 2 here. We have a 3 here and a 3 here. And one of these is 2 or 3. One of these is 2 or 3. If we try to have 2 3s here, that's not possible because we have a 3 in this column and 3 here, which is in rows 4, 5, and 6. That would force 4 3s to be in 3 rows, which is not possible because without a duplicate. So we cannot have 2 and 3 in any of the remaining digits or cells in rows 4, 5, and 6, which is not in one of these two cells or in column 2 or column 8. So this cannot be 2 or 3. It's 4, 6, 7. Can this ever be 9 is kind of the question. This can't be 9 because it's sharing an edge with a 9. And if we try to have a 9 here, you would have to be 3, 4, 5, 6, 7, 8, 9. That would be 3, but then we'd have 2 4s here, which is not allowed. So this can never be 9. So therefore, one of these is guaranteed to be 1. Since one of these is guaranteed to be 1, it must be a 1, 2, 3 triplet. So this is 1, 2, 3. We have a 2, 3, 2, 3 pair in column 6, which eliminates 2 and 3 in the rest of the column. So this is 2, 3, 2, 3. This can't be 1 through 3. It could be 4, no 5, because it doesn't have a 1 above it, or 9 below it. So 6, 7, 8, and 9 is possible. Again, 9 cannot be here. So this cannot be 5 and 9. But it could be any digit from 1 through 4. And we have a 1, 2, 3, 4 quadruplet in row 4, which eliminates 1 through 4 in the rest of the box. But it also forces this to be a 1 through 7 rin band, so this can't be 8. This digit then is next to... Oh, this could be 4. Dang it. Okay, so that's actually a bad assumption I made. Because these don't have to be different digits. Oh, but this has to be 6 or 7. Yeah, that can't be 4. So this is... Okay, never mind. The logic I had for the 2 3s pair was still valid. That's fine. These two have to be different digits, but these do not. But this can't be an 8. So that's the reason why this couldn't be 4. So this could still be 2 or 3. This is 6 or 7. Okay. One through 4 has to be 4 or more away from 5 through 9. Cannot be 9 here because of a 9 in the row. This can't be 2 or 3. So this is 1, 4. Cannot be 5, 6, 7, 8. We are guaranteed 5 somewhere in row 5 because it's the digits 1 through 9. Cannot be here because of no 1 above it, no 9 below it. Cannot be here because it can't have a 1 above it or 9 below it. Can't be here because 5 in the column. Can't be here because 5 in the column. Can't be here because it can't have 1 or 9 above, 1 above it or 9 below it. This is 9. Again, cannot be here because it can't form a 1, 2, 3 or cannot form a Renban with 1 or 9. And it can't be here. So this has to be 5. This is 5, which makes this 1 to have a 1 above it because it can't have 9 below it, which makes this 9. That's 5, which makes this 1. So this can't be 1 here. This is 5 with a 1 above it, 5 with a 1 above it, 5 with a 9 below it, 5 with a 1 above it, 5 with a 9 below it. Okay. This can't be 9 because of a 9 in the column. Remaining digits, so this cannot have a 5 here now. So this has to be 4 then. Because 6 or 7 require a 5 here to be consecutive with this low digit. So this has to be 4, and this becomes a 2-3 pair here. That means we have a 2-3, 2-3. This 4 eliminates 4 here. This cannot be 4 here. Where's the 4 in column 5? It has to be here. So this is 4. That leaves this digit as 6, 7, or 8. We have a 2, 3, 2, 3. We have 1, which makes this Renban be 1 through 7. So this cannot be 8, which means 8 has to be one of these 2. That doesn't tell us very much. We have a 2, 3, 2, 3 pair in column 4 also, which eliminates 2 and 3 in the rest of the row. So this has to be a 4 here. That 4 eliminates 4 in the rest of the row. So this is a 6, 7, 8 triplet. That's fine. Okay. Let's start coloring then. We're gonna make this red and yellow. That forces this to be the red 2, 3, which forces this to be the yellow 2, 3, which forces this to be the red 2, 3. This must be the yellow 2, 3. We have a 6, 7, 8 triplet in row 5, which eliminates 6, 7, 8 in the rest of the rows. This can't be 6, 7, or 8. It's 1. That eliminates 1 as a possibility here, so this is 2, 3, and 4 here. This one also eliminates 1 here. So this is 2 or 3. This is 2 or 3. Obviously, this is not the red 2, 3. So the red 2, 3 is one of these two. And then the red 2, 3 is one of those two. We're not sure which. What about 6, 7 pairs? Can we form anything there? We're gonna make this green and this pink. Green has to be one of these two, but that doesn't tell us very much. For this to be 3, this has to then be 7 and 7. Is that a restriction there? Oh, this 1 eliminates 1 here. So this must be a 2, 3, 4 triplet here. That doesn't help. So can this be 3 and 7, 7? I would guess probably not, but I don't know. Let's try this. If this is 3 and 7, 7, that would make this 2, 3, this is 2, this is 3, that's 2. So we have 7 here, which makes this 6. This can't be 6 or 7, it's 8, which forces this to be 7. Okay, that works fine. This cannot be 4, so this is 2, which makes this 4. So this must be 3, that makes this 2, that makes that 4. So far it's looking fine. This can't be 7 or 8. It's 6. This can't be 6 or 7. It's 8. Which makes this 6. All the 5s have a 1 above it or 9 below it. So 5 has 9 below it, 5 has 1 above it, 5 has 1 above it, 5 has 1 above it, 5 has 9 below it. That forces this to be 3. So far this is looking fine. This becomes a 6-7 pair. Yeah, this seems valid. Huh. Difference of 4. 7 is 4 away is 5 away from 2, which is 7 away from 9, which is 4 away from 5. 2 is going to be 4 away from both 6 and 8, 7 or 8. 5 is 4 away from 9, which is 8 away from 1, which is 4 away from 5. 7 is 4 away from 3, which is 4 away from 7, which is 5 away from 2. 1 is 4 away from 5, which is 4 away from 9, which is 8 away from 1. So this satisfies all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 through 7 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 through 7 here. 5 through 9, 2, 3, 4. Whatever digit. 7, 2, 3, 4, 5 through 9 here. 1 through, this is 7. So this has to be a 6, 8 pair here. This all seems to work. Why can't it be 2 then? I don't think... So say this was 2. This is 2. This is 3. 3, 3. So this cannot be 6. Which would force this to be 6, this to be 7, this to be 6 here. 3 can only be next to 7 or 8. This is 2, obviously. This can't be 2. This... that's the problem. Because this is 2 and it's the same as that, this has to be 3. Okay, so the bad assumption then is if yellow is 3, that forces this to be a 7-8 pair, which forces this to be 6, which makes that 7, which makes that 6. And yes, this... Okay, so it's actually this digit is between 2 unique digits on a Whisper 4 line. And 6 cannot... And neither of them could be 1. So therefore 6 cannot be here. This has to be 7, which makes this 6, which makes that 7. So this cannot be 7 here. This becomes a 6-8 pair. That forces this to be a 2. So all the yellows have to be 2s. So these are all 2s, which does force this to be 3, which does force that to be 7. This can't be 1 or 3. It's 2 or 4. This can't be 1 or 3. It has to be 2 here to be next to the 7. So that's 2, which makes this 4, which makes this... This 2 eliminates 2 here, so it's 3, which makes this 2. Which makes this 3. That makes this 4. This can't be 6 or 7, so this is 8, which makes this 6. This can't be 6 or 7, so it's 8. 7 eliminates 7 here, so it's 6. Can't be 6 or 8, so it's 7. Okay. This 8 eliminates 8 here, so it's 6 and 8. Okay, there it is. And this 6 eliminates 6 here, so it's 7 and 6. This can't be 6 or 8, so it's 7. Yeah, I got a little stuck there. I should have seen this Whisper 4 issue, but I just didn't. And then I went down this path, and it worked fine. So I was just like, okay, it can't be this. This path has to be the correct path. Interesting. Yeah, I don't know. My brain turned off on the Whisper 4 lines for some reason. I didn't think about it that hard. Well, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.